The next one, two of a kind. Two were different. And one other. So, here's what you have to do. How many kinds are there? 13 of them. Now, there are going to be 13 different cards, or 13 different kinds. You want to choose two of them. Because they say two of a different. That way you're picking two different cards. Two different ways can you pick two different cards. Does that make sense on that first part? Now, for both of those kinds, how many cards are there? 4. How many of each do you want? You have to do that twice then. How many cards are left?
Can you explain that? Basically what you just said, but I think I didn't hear it right.
Here's you have your 13 kinds. You have two of a kind, and this is two of a different kind. So you want two different pair. Otherwise, you'd say 4 of them. Is that sort of with that?
You want two different or not?
By doing it this way, 13C2, you're making sure that you're picking a 7 and a jack. It's not allowing you to get two sets of 7s. It forces it to make sure that both the kinds you choose are different from one another. Once you get that, you want 2 of both types. There are 4 7s and there are 4 jacks. How many ways can you get 2 of the 4 jacks? How many ways can you get 2 of the 4 7s? That's where those come from. And then just the one other card, well, we've taken in consideration here 8. How many cards are left then? Shinky!
And you do 13(1) times 4C2 times 12C1 times 4C2.
Does it get the same answer?
I don't know.
Try it.
I'm assuming it will.
I don't know. You might make an angle side out of you and me though. You gotta be careful with that.
Wow.
No, it wasn't. Go.
Like, I understand what you can use this for to find, but when are you actually going to have to use that? Is what-
Go to Vegas.
Just that.
Probability statistics, when we're looking at these are just counting principles. We haven't even gotten to the actual pure probability stuff yet, favorable over total. It's just a way of running numbers. Ways that things can occur. How many? What's your possible chance of winning? What's your? I don't want to say odds because that's a little different, but what are your probables that are out there for you? To be honest with you, there is the easiest way to show how statistics and probability work is via gambling, just card games, things like that. How often something can occur because it is a tangible thing. You can play cards. You can see how those numbers go. It's not like we're working with imaginary numbers like I am right now. You know what I mean? Where are we at? 3 face cards of the same suit and 2 other cards. I think this one is the toughest of them all because it's weird. We'll start with that. 3 face cards with the same suit. The idea here is that you have to have the same suit. How many suits are there? 4. How do you get the same suit? Pick one. And now you want face cards. How many face cards are there in that suit? How many of them do you want?
1.
You want 3 of them.
Oh, yeah.
And now it's at 2 other cards that are not face cards. So in a deck of cards, how many are face cards?
12.
In a deck of cards, how many cards are there?
52.
Take out the face cards, what are you left with?
40.
How many do you want?
2. This is so confusing. Yeah.
Yes. I'm getting there. I'm trying to get this done.
Patience.
You know, I'm getting there. I have the stack of piles. It's out. I started meandering about with this. I should be able to finish what we're doing today with time.
Patience,
Okay.
young man.
I had it all planned. Like I said, I got a phone call that I had a sick kid at school. I had to go pick him up, take him to the doctor, and it was strep. My wife is finishing, she teaches AP and Honors Chem at Camelin. They had their last big lab yesterday, Monday, Tuesday, so she couldn't stay home with him because the chemical stuff, it just exploded and bad things would happen. So I had to, otherwise it was her turn to stay, but I had to because she couldn't.
See who wears the pants for this
Wow. I felt that one.
Don't come back.
Hey, no comeback. No redirection.
You know what to say to that. For once, I might be speechless. Yes, sir.
Hey, what did you think of all those Usain Bolt stories?
It's really stupid. I don't appreciate it. Yeah, I already talked to him. Okay, because there are a lot of pictures on there, pictures, you know, like my kids and stuff like that, and the things that other people have signed is kind of, it's not cool. Anyway, the last little bit on there was the rectangle one. 1, 2, 3, 4, 5. So the first one you had a 3x5 rectangle. And if you read the instructions, it tells you, hint, a rectangle is formed by choosing 2 vertical lines and 2 horizontal lines. How many vertical lines are here? Oh, wait, there should just be 5. I'm on the wrong. Wait, 1, 2. Oh, there was 6. Sorry. How many vertical lines did it tell you to choose? 2. How many horizontal lines are there? 4. How many of those are you supposed to choose? 2.
Why don't you have all the ones in between?
Because this line is the same as this line is the same as this line because it's all one line. So this is 6, 5 over 2. And this is 4, 3 over 2. 15 times 6 is 90.
Wait, I don't understand. Like, I can make way more than 90 rectangles.
You can.
I got 81 by now.
I don't understand. Wait, how many?
Yeah, I
get it. Wait. Don't you count like all the verticals and horizontals?
No, it shouldn't be just ask that. Because isn't this vertical line, and this vertical line?
Okay, but this rectangle is the same thing as this rectangle.
Correct. But by counting the number of, you want to pick 2 vertical lines and pick 2 horizontal lines. So if I just pick this one, and then I take this one and this one, well, here's rectangle here, it just counts itself through. Yes, sir.
Would it take you be on the like the denominator? Would it be like 2 times 1? You just didn't put the 1 there. Or
Yeah.
Yeah.
Remember, when you're doing these combination ones like this, when it's 6, 5, 4, 3, 2, 1 over 4, 3, 2, 1, 2, 1. That's where I was getting 15. Okay, that's how that works. Other side is a little bit more than that because I think there were, what was it? 1, 2, 3, 4, 5, 6, 7, and 3. So the big changes it up. I think it's 126 when you do it.
Yeah.
Okay. So let's look at the other part here. When we got into Pascal's triangle. The last little bit of this section is the Pascal's triangle stuff, and that stemmed from when you start making a triangle with 1s on the outside.
Good old Pascal. You can always rely on his
For polynomials, as you go through this, or better yet, as you're starting to look at how Pascal's triangle is developed, each number that is directly below, it can be written from the sum of the 2 above it. So here, as we start going through here, there's a middle term here because there's two numbers above it. What's 1 plus 1?
2.
There's a term here and here now because there's a number here and a number here. What's 1 plus 2?
3.
2 plus 1.
3. That's cool.
What's 1 and 3?
4.
3 and 3.
6.
3 and 1.
4.
1 and 4.
5.
4 and 6.
10.
6 and 4.
10.
4 and 1.
5.
And so on and so forth.
Does it go down?
Yes. It follows the rules of polynomials and it follows the rules of exponents. For example, 0. What I want you to see here is if I take a polynomial, remember when you have a square, if I take a binomial and I square it, that's junk squared. Do you agree? Junk squared gives you junk times junk.
Doorbell.
Hi, how are you?
Good, how are you?
I'm fantastic. Thank you.
Alright.
So what happens here is you start foiling things out. If I take x plus y times x plus y and I foil it, you get x squared plus 2xy plus y squared. What are the coefficients of those three terms? 1, 2, and 1. 1, 2, and a 1. One, 2, and a 1. Convenient, isn't it?
Yeah.
If I raise that an x plus y to the third power, junk cubed, I'd have to take this x squared plus 2xy plus y, and multiply it again by an x plus y. And if I do that, I'd FOIL it out. When I FOIL that out, I'd get x cubed 2x squared y, xy squared, sort of it. And then I get plus x squared y, 2xy squared, and a y cubed. Sorry about the writing there. I wrote triangle too big. Combine your like terms and look what happens with your coefficients. X cubed, 3x squared y, 3xy squared, and a y cubed. What did that match up to? It matches that. When you have a third degree polynomial, how many separate terms can you have? 4. Remember, you'll have n plus 1 possible terms in the polynomial, n possible zeros. N minus 1 changes the direction. Remember all that? That's where all this polynomial stuff that we looked at a long time ago comes back to play. So what you're doing here by using this Pascal's triangle is that it's allowing you to figure out what all of the coefficients, the multipliers are going to be for a regular binomial that does not have larger coefficients. What's up? No, she can't go. See you guys. This works for all nth degree binomials. Yes, sir.
I'm not following where the x plus y squared.
I made it up.
Just
It could be anything. It works the same if we had the quantity x plus 4 to the 4th. If I want to use this idea of this Pascal's triangle, there's another pattern that I want you to see. All of these numbers, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, all of those numbers come from combinations. Each one of these, if it's a second degree polynomial, this is a, excuse me, a 2, choose nothing, 2, choose 1, 2, choose 2. The next one would be 3, choose nothing, 3, choose 1, 3, choose 2, 3, choose 3. Fourth degree. 4 choose nothing, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Because a fourth degree polynomial will have how many terms? 5. So you get this pattern that happens. You have, how do I write this out? Here's what I would do. Oh, it's squared. That's too easy. We'll go to the 6th. Make it a 2. Here's what I do. No matter what, I'm going to write these things in terms of A's and B's because I'm going to use substitution back into it. And since I know how much you guys love when I start with the easy stuff and you go, wait for the
Sounds just like
it does. Oh, I get it. It'll be easy peasy. Lemon squeezy.
This is a child's play.
This is chop. I can't do your voice. So I'm going to do this. 2x
This is child's play.
plus 4y. He wants to put it in the jello. Trying to be Bill Cosby there or something?
No, I was imitating you, imitating me.
Oh.
You had like a southern accent.
I say. That's Bob
Marley.
I am nothing but a southern gentleman. Here's what I do. I'm going to let A be 2x and B 4y. We're not foiling, we're multiplying out. We're not factoring, excuse me. We're foiling stuff out.
If you factored out a 2, would you just multiply your
Can you do it so that 4y is like squared? Are you good with that?
Maybe, I don't know. If it's squared, then you just raise it to the next power like I was showing you earlier. How do you do power to power? So here's what I do. I'm going to write this as A plus B to the 6th. Which means my first term is A to the 6th. My next one is A to the 5th because it goes down in degrees. But now the B shows up. The next one is A to the 4th and B to the 2nd. Because all of my exponents, when I put them together, are always going to add up to equal whatever my nth power is. Always. Next one, A to the 3rd, B to the 4th, A squared, B to the 5th.
No, it's B to the third.
Oh, I can't count. All right. Notice that the first term degrees are going down. It starts at the top and it ends at 0. The first one starts at 0 and goes to your end. They go the opposite directions.
Heck yeah.
That's how these work.
It's just one. Heck yeah.
Yeah, it's a shortcut way to do it. Much, much easier. Now, the other thing is that your first term is always positive. Always. Since this one is positive, that means all of them are positive. If this was negative, my first term would be positive, my second term would be, then it would be, it just flips all the way around. All right, first term would be positive. If this is positive, everything is. If it's negative, the second term is negative, and then it just alternates through. So I know this is going to happen. Before I substitute in what A and B is, I got to find out those coefficients, and that's where I use the combination signs. This first one is going to be 6, choose nothing. You're always going to start with that 6 for the C value. What's up? Notice they're towing your car. The next one would be 6. What do you think the next one's going to be? 1. Here's the trick. Look at the relationship with the second number. Look at the second number in the C value. What's it matching up with?
Nothing.
The B. It always matches the B value. That 6 choose 0 Well, our b value in the first term of the sequence is b value is 0. 6 choose 1. Second one's b to the first power. B squared, b third, b fourth, and so on. That matchup always happens. Okay? It always happens. Yes, sir.
So if we were to put this in terms of playing cards, your A would be anyway.
Are you gonna let him do that to
Anyway, so here's what happens. When I have these problems, especially when you have terms that are not single values, 2x, 4x, or 2x squared, 4x to the third, things like that, I always write them in A's and B's because it's easier to see what's going on. And I'll go back and substitute later. I'm going to find all these numbers. 6 choose 0 is 1. A to the 6th. The next one is going to be 6 choose 1, which is 6. And then it's A to the 5th, B to the 1st. The next one is 15. Is it?
Yeah.
The next one would be 6, 5, 4, 30? 20.
Where are you doing that from?
The A's is what we did, and now it starts going backwards.
Now it goes down. Then it goes 15.
And 6 again.
And now you know what your A's and B values are. So now you substitute those in. A was 2x, B was 4y. Move this up a bit here. So I have 2x to the 6th plus 6 times 2x to the 5th times 4y plus 15 times 2x to the 4th, 4y squared, 20, 2x cubed, 4y cubed, 15, 2x squared, 4y fourth, running out of space. Uh, 4y sixth. Sorry about that. Yeah, and this is where you just start multiplying things together. 2 to the 6th is 64, I believe. So we have, oops, 64x to the 6th. Because remember, when you have that jump to the 6th power, both terms inside the parentheses need to be raised to the 6th power. And that exactly is where you guys are going to mess up. It happens pretty regularly. I already had some third hour come in and say, what did I do wrong? You forgot to throw it in parentheses and go through it. So you have 24 times 32. No idea what that is.
So,
Wait, you're talking about 2 to the 5th times 6?
7/16.
Then it's 15 times 16 times 16.
38, 40.
20 times 8 times 64.
10, 24, 0.
Then it would be what? 15, 4, and 256?
15,360.
15,200?
I'm gonna get the next one.
360.
I got, yeah, 15.
So you turn yourself around. Sorry.
Oh,
2 to 6, and I have no idea what 4 to the 5th is.
The total is 12288.
1, 2, 2, 8, 8, x, y to the 5th. Now can you see why I wanted to show you guys something that's absolutely awful. So when you see the easy stuff, you'll be like, and then 4 to the 6th is
4096. Is this the worst?
well, Bella had a good question about what happens when you have this. If you have 2x minus 3y cubed to the 7th power. The biggest mistake you're going to remember when you're getting into these parts here, it's going to be 3y cubed to the 7th at some point, which means it's 3 to the 7th, y cubed to the 7th. So it's 3 to the 7th times y to the 21st. Remember your power rules. That's about as nasty as something can get. The other one that was on there is, if I go back to that sheet, there's one question where it asks you, find the coefficient of the x to the 6th in the expansion of 3x minus 2 to the 10th. They're trying to find the coefficient. Now, in this case, you're looking for something with x to the 6th. I'm on the B side. Very good. What that means is that this power here, this has to be raised to the 6th because it's 3x to the 6th, so that would be the 6th part of x. And that means that the other part, the negative 2, would have to be raised to the 4th because these two, correct. That has to work. And what's the choose thing that goes out in front? Yep. And that's how you do that. That's how you find the coefficient. Now remember, when you're doing the stuff that has a negative value for that b part, that, as long as you throw it in parentheses before you raise it to your exponent, that's how it alternates the signs. Because as the b value is negative and you get an odd exponent, it's going to be negative. If it's an even exponent, it's going to be positive. Did that make sense how I pulled that one out like that? It can get goofy. I have seen, I don't know if I've done this to you yet or not, but I have seen this question before where the binomial might be 2x squared plus 1, and it's trying to find the x to the 8th part in something of the 12th. Which means what would your term have to be? So what power would the first one have to be? 4. Very good. Yeah.
If it's like a multiple choice thing,
Yeah.
is there a way to flex that to find out?
For just picking the coefficient, like whatever the answers are? I don't think there is. But there's no quick, it really isn't like a quick plug and chug type thing for this, because you're not like a, because if you go into your table, that won't get you anywhere because you're looking for the 6th term in a 10th degree polynomial without multiplying it out.
Well, if you got your graph and every change, like,
Not necessarily, because it doesn't mean that at that spot that there could be. Because remember, you could have n up to n minus 1 changes of direction. Now, with this being a binomial to the 10th power, that means it's 3x minus 2 10 times. What's your only 0? Two-thirds. So it's just at the origin at 2/3. This is going to look like a parabola. You're not going to see all those different changes. The change of directions aren't shown because of the way the binomial is written. Does that make sense? Yes, sir.
Where did 4 come from 10 choose 4?
We know that the 3x quantity there has to be to the 6th power to get an x to the 6th. Your exponents, these values, always add up to equal your nth root.
Okay,
So 6 plus what gets you
that's
10?
the A and the B.
Yeah.
So
'Cause
it's the power of A plus the power
Yep.
of B.
See how this would, you're at a 6th degree polynomial? 6, 5 plus 1, 4 plus 2, 3 plus 3. That's how that works. Yep.
I don't know if this is a dumb question. I always say there's no such thing as a dumb question, but I know I've asked some before. So when we do the permutations and combinations, let's say whatever it's 1p4, I don't know, are we solving for P? Or
No,
is it just?
alright, it'd be P4, P1.
Right.
What happens here is when you're looking at permutation and combinations, you're looking at how many possible things can occur, events occurring. Now, with a permutation, the order matters. How many different ways can you take a book and put it on arrange a book on a shelf? How many ways can you take 4 books and put it on a shelf? If you place book A in the first spot, you can't put book A in the same spot as the 4th spot, because it's already here.
Oh.
Okay, whereas how many different ways can they be arranged? Well, then that order doesn't matter how you put them in. That's the difference between a permutation and a combination.
Right. Right.
Distinct, yeah.
I'm glad I got that.
It takes a little bit of time, okay? Yes, ma'am.
So Pascal sparkles and related combination.
Yeah.
Did you just take the like the 2 and the other one?
Yeah, because remember this value here for your C value is always going to match the second part. It always matches the second part's, what do you call it, power. That crazy Pascal. I think that gives you guys enough to finish out Pascal stuff. If you have not quite figured it out or finished it, we'll do that for manana. I did have another one I got to find for. Let me find this other question real quick.
It looks so weird. What you're thinking.